So determinants. Who doesn't know determinants? Almost every of us do. I will have a traditional way of solving determinant, which is plus, minus, plus for 3 by 3 matrix. We also have, for 3 by 3 matrix, we have plus, minus, plus. This is the traditional way. For 2 by 2, we have plus, minus. We exchange the numbers as the case may be. So today I want to introduce us to properties of determinants and how we can use it to solve determinant question such as the one we have here. So let's look at the first property of determinants. 1. Add 2 rows or column and 2 rows or columns. The determinant does not change. The determinant does not change. The determinant do not change. Do not change. Let's see a typical illustration. Let's assume we have a 2 by 2 determinant, 3, 1, 4, 4, for instance. So to solve this is 2 by 2. I will just put plus and minus. So this to this, this to this. I'm having 3 into 4. I'm having 1 into 4. That is now 12 minus 4. Our answer is 8. This is the traditional way of solving determinant question. So let's apply the property now to solve the determinant by adding 2 rows or 2 columns. So this is row 1, this is row 1, this is row 2. While the whole of this is column 1 and column 2. So I can add 2 rows or 2 columns. Like I said, the property says the value of the determinant will not change. Let's see how that works. So let's start by adding 2 rows. So I will have 3, 1, 4, 4. So if I add 2 rows, that will give us new row 1. I want to obtain a new row 1, which is row 1 plus row 2. If that should happen, here becomes 4, 1, 8, 4. So what are we having? If I apply the concept of traditional method of solving it, this to this, we're having 4 bracket 4 minus 8 bracket 1. That will give us 16 minus 8. The answer is 8. The same is also true. We can equally subtract 2 rows or subtract 2 columns. Let's also see how that works. So we're having 3, 1, 4, 4. So I want to get new row 1, which is row 1 minus row 2. If that should happen, here becomes 2, 1. Here is now 0, 4. Because this minus this minus this. Plus minus, I'm having 2 bracket 4 minus 0 bracket 1, which is 8 minus 0. Our answer is 8. See, nothing change. So let's apply this property to solve the question we have at hand. Let's apply this property to solve the question we have at hand. So let's go. So we are having determinant x plus y, x plus y, x, 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 x plus y, x, 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 x plus y to give us 3x plus y, open bracket close, y squared. We have to establish this proof. So for me to obtain 3x plus y, I can add the three rows together. So that will give us new row 1. My new row 1 now will be row 1 plus row 2 plus row 3. So let's see, what would that give to us? If I add the three rows together, that here will give me 3x plus y, 3x, going to have also 3x plus y, 3x plus y. So here remain x plus y, x plus y. These are determinants. So you can see for the first row, you can see 3x plus y is common. So let's factor it out, just as we did previously. Let's factor it out, the common factor. Let's factor out the common factor, just as we did previously. So if I factor 3x plus y out, I'm going to have 3x plus y as a common factor. Now here remain 1, 1, 1. Here is x plus y, x plus y. So let's also not apply our traditional method, plus, minus, plus. Let's see what we can do to simplify what is left. So this time around, I can also deal with columns or also row by obtaining new row 2. So my new row 2 will be row 2 minus row 3. New row 2 now is row 2 minus row 3. So I'm subtracting everything in row 2 from row 3. What would that give to us? I'm having 3x plus y, 1, 1, 1. So new row 2 now is row 2 minus row 3. So x minus x is 0. So here is now 0. Then x plus y minus x, that will give us y. Here's now y. Then x plus x minus x minus x minus y, we're going to left with minus y. We're having x minus x plus y. If I simplify it, I'm having x minus y. Minus x and minus x is 0. We are left with minus y. So here we are left with minus y here. So here remain x plus y. So from here, I can simplify now by doing our normal plus, minus, and plus if I want. So let's go with plus, minus, and plus. So I will take the first one, which is 1. I'm left with y, x, minus y, x plus y, minus 1. Here remains 0x, minus y, x plus y. Then plus 1 remains 0x, y, and x. So if I simplify, I'm having 1 into xy plus y squared plus xy minus 1 into, here is 0 plus xy, here is plus 1 into 0 minus xy. So if I should open the bracket in both cases, I'm going to have 2xy plus y squared, then minus xy minus xy. So you agree with me, minus xy, x1 is 0, we are left with what? Y squared. Therefore, our result now is 3x plus y bracket y squared. This is the proof we are asked according to the question. So if you like what you're watching, we have exciting topics here in physics, chemistry, maths, further maths, including technical drawing and computer science. So subscribe to the channel, like, share, and comment. This is STEM Up Africa. This is STEM Up Africa. It's our YouTube channel. Support us by liking, sharing, and comments. Subscribe. Thank you.